it's been a tremendous journey and really exciting to see the tremendous growth, both in terms of the volume of archives that customers are storing on Glacier, as well as the breadth of use cases that customers are using Amazon Glacier for. And ranging from media and entertainment, financial services, government institutions, healthcare and life sciences, and many more. And I want to start today by talking about and highlighting some of those use cases and a couple of customers who have built some pretty cool applications using Amazon Glacier. So to start with, for the musicians in the house, SoundCloud is a great example of storing mission-critical data on Glacier. SoundCloud is a leading social platform that enables musicians to create their music, upload it into SoundCloud, who then transcodes that into a low proxy resolution format that makes it easy for them to share with their fans or other musicians for collaboration, to share onto other social platforms. And SoundCloud then stores the original copy, the raw copy of the musicians into Glacier, and they really leverage the durability model of Glacier to safely store that data for their end users, which is really invaluable to their end users. So, and today SoundCloud is storing petabytes of data on Glacier. A large number of enterprises and government institutions alike are using Amazon Glacier to compliantly store data, sensitive data, that are bound by various regulations. And a good example of that is Philips Healthcare, who runs their healthcare digital, Health Suite digital platform on AWS. And they leverage Amazon Glacier, which is one of 9 HIPAA-eligible services on AWS. Philips Healthcare loves that Amazon Glacier is highly scalable because they operate in over 1,500 hospitals that generate patient data and medical images on a daily basis. And they require that compliant service. And they also need that service to be highly cost effective because they are required to store their patient data for the lifetime of that patient. So we're talking about decades and cost really matters to them. A local example from Seattle, King County uses Amazon Glacier to replace their old legacy tape systems, which they used for backups for 17 locations around the Seattle area and King County. They found that they were able to save over $1 million in just the first year, as well as avoid that high-touch maintenance of old legacy tape hardware systems. And as a government institution, they also needed to meet various regulatory requirements, which they were able to either meet or exceed using Amazon Glacier. And lastly, I'm very excited to have our special guest speaker, Andy Shenkler from Sony DADC, speak today in detail during the later half of this presentation on how they're using Amazon Glacier to power their new digital media supply chain solution Venue. So stepping back for a moment to look at storage on AWS as a whole, customers have taught us over the years to look at cloud storage based on 4 key elements, and that's file, object, block storage products supported by a number of batching and streaming features that help you make the most out of those storage products. The customers I've talked to have told me that they consider AWS really as the gold standard for cloud storage. And they love leveraging the breadth and the depth of those products and the features that we offer. And we continuously are receiving feedback and requirements and continue to iterate very quickly to meet those customer requirements. Customers for a long time asked for file systems, for example, that worked at a petabyte scale with really consistent latency, and so we launched Elastic File System that is both highly scalable and very performant. Amazon S3 and Glacier are object storage that is very highly durable and very cost effective and great for everything from cloud native applications to large big data workloads. And then finally, Elastic Block Storage is the lowest latency offering in our portfolio and offers everything from provisioned IOPS to low cost throughput optimized storage offerings as well. And then finally, we have a whole slew of batching and streaming products and features that help make the most out of these storage products. Regardless of the industry or the type of storage, we've seen really a trend of just exploding data, an explosion of data across all industries that have been driven by things like the proliferation of data-producing devices like cell phones and IoT devices, higher data formats, larger data formats like 4K, 8K, advancements in new health and life sciences, such as genomics data. A single genomics sequence can take up to 1 terabyte of data these days, and that increases as that technology gets better. And in general, there's kind of a virtuous cycle in storage where as the prices of cloud storage have dropped, customers are storing more data for longer, extracting more value out of that data, which then increases the demand and therefore the scale that AWS can operate at, which in turn reduces our costs, and we pass those savings on to you in the form of lower prices. Case in point, last week we announced a storage price drop for both S3 and Glacier for as much as by as much as 43%, which we're very excited to pass on to customers. So really, regardless of the use case or the industry, companies face large and fast-growing storage requirements, and many face the challenge of finding a solution that's both scalable, cost-effective, and offers the performance that they require to best monetize their data. So in this session, I'm going to discuss how Amazon Glacier is really designed to address those concerns, in particular for archival workloads. So whether this is your first time hearing about Glacier because you're considering moving an archival workload onto Glacier, or you are already using Glacier and are looking to find out more about new features that can help you better optimize your archival workload, I think you're going to get a lot out of this presentation. But if there's one thing that I want you to get out of this presentation, other than excitement that it's finally time for the pub crawl, it's that Amazon Glacier is more than just a solution for deep archival to lower your storage costs. It, especially with the new retrieval features that we launched last week, it is really a powerful storage solution that can address the full spectrum of archival use cases. So let's start diving into Amazon Glacier. First of all, it's extremely low cost. We start at 0.4 cents per gigabyte per month. We offer 3 ways for you to get at your data that range in both price as well as performance. They range from accessing your data in minutes to accessing it in hours in a more cost-effective way. We offer 11 nines of durability. What does that mean? In mathematical terms, it means that if for every 10,000 objects that you store, you can expect to lose 1 every 10 million years. So even that's hard to wrap your head around. If you're using tape, what is that? What would be a good comparison? We asked a Hollywood studio, major Hollywood studio, to run the same Markov model that we used to derive the 11 nines, but for 2 copies of their data on tape. And what they came back with was 5 to 6 nines of durability. And so to have 6 additional nines of durability using Glacier, what that means is that Glacier is 5 orders of magnitude more durable than 2 copies of your data on tape, which is a common durability model used for tape. All data on Glacier is encrypted at rest, regardless of how you pass it to us. You might encrypt it beforehand, but we will then encrypt it again. All data that comes onto Glacier is encrypted at rest. And then finally, we have a set of features around both compliance, access control, cost management, et cetera, that I'm going to dive into. From a value proposition standpoint, Amazon Glacier removes the need for upfront capital expenditures that, in particular in the archive world, is particularly meaningful considering the long investment periods that are involved with archival solutions, hardware solutions, which increases the risk of involved with having to live with that decision for many years, 7, 10 years, what have you. With Amazon Glacier, there's no upfront commitment. You pay only for what you use, all that good cloud stuff. We also removed the need for time-consuming capacity planning and ongoing negotiations with multiple hardware and software vendors, the risk of managing physical media, as well as empowering you to control your geographic locality, your performance, and your compliance requirements as well. So to begin diving a little deeper, I want to cover some of the basic terms for Glacier, as well as the concepts that I'll be covering in this presentation. So first of all, with your AWS account, you first use Glacier by creating a vault, which is our term for the container that you store data in which you store archives. And archives are the basic unit of data. Archives are write once. They can be up to 40 terabytes. And you can store an unlimited amount of archives in a given vault. And then we also have this notion of an inventory, which is a cold index of your archives, and this is refreshed every 24 hours. So the four areas that I want to cover today are around how to access Glacier, how to upload your data, how to manage that data and to manage your Amazon Glacier account, and then also how to access your data and make the most out of your data. And I'll be going over best practices, how to optimize those things in detail. So first, accessing. There's 3 ways to access Amazon Glacier. The first is directly by using Glacier's APIs or through its SDK, which gives you access to the full set of APIs and is a great way to build applications on Glacier. Like any AWS service, it's really important when you're setting up a service or an account to always be thoughtful and diligent around setting the right access policies for your accounts so that you're meeting your security requirements around who can access what, or delete, or retrieve, et cetera. And oftentimes, with archival workloads, it involves mission or business and critical data, so very important to do that. If you are already using Amazon S3, or if you have both an online and in conjunction with an archival storage layer, then accessing Glacier via S3 Lifecycle is a great way to go. It's an automated way to tier your storage into the lower cost storage options, and I'll be going into that in detail later. And then lastly, there's a large number and an ever-growing number of third-party vendors who are integrated with both S3 Lifecycle and Glacier that make it easy for you to manage your data. And they range from consumer-grade tools like Fast Glacier and Cloudberry to all the way up to enterprise-grade gateways and appliances such as NetApp AltVault or Commvault. One thing to keep in mind with third-party vendors is that some of them will reformat your data for various purposes like indexing or to optimize the data transfer process. And then this makes it necessary to continue to use that third-party vendor once that data is in AWS for leveraging it for analysis or other types of workflows, which might be fine depending on what your use case is, but a lot of customers find it really useful to keep that native format of their data in the cloud, not be tied to a third-party vendor when they're considering different ways to utilize that data. Just something to keep in mind when you're exploring third-party tools. And a quick reminder, when you're uploading data, we have several really powerful tools and services that can help you transfer, in particular, large amounts of data. So if you have large amounts of data to transfer either as a one-time migration or on an ongoing basis, AWS Direct Connect gives you a dedicated bandwidth between your on-premises infrastructure and AWS, up to 10 gigabits per second per uplink. And then AWS Snowball and the recently launched Snowball Edge are great ways to not only transfer data cost efficiently, but in many cases, if you have lots of data to transfer, it can be actually faster than the public internet. So when you're uploading data into Glacier directly through its APIs, we will pass you back an archive ID and then throw away the file name. And then customers then maintain a local index mapping their file names to their archive IDs. And one thing some customers miss is that we enable customers to include a description of up to 1,024 characters along with that archive as metadata. And so some customers find it useful to create a replica of the index information in that description field in case something were to happen to that local index. So that's one thing to keep in mind. Another tip is that Glacier is really designed for objects, for archives, where your data set, the average archive size is in the megabytes at the very least. And the reason for that is because there's a 32 kilobyte overhead charge for every object archive that you store in Glacier. And so if your average archive size is 3.2 megabytes or higher, then your total overhead charge will be less than 1% of your total costs, which most customers find reasonable. If your average archive size is less than that, then you might consider aggregating your data before you upload it. And when you're aggregating, one tip that customers have used is to include a checksum along with those files that are being aggregated into a larger archive, so that when you retrieve that data, you can ensure that you're getting the bytes that you want. And this becomes particularly important when you leverage range retrievals, which is a feature that I'll go into at the end of this presentation, which allows you to pull just a byte range, a range of bytes within the archive, rather than pulling back the entire archive, so that you can minimize your retrieval costs in that way. And then the checksums become important for validating that you're getting the bytes that you really want. And lastly, in terms of uploads, a lot of customers use multipart uploads to optimize that transfer into Glacier. You know, a lot of customers find that HTTP is great because it's a widely adopted standard and all, but it's not great oftentimes for very large archives, for transferring very large archives. So to both help ensure that that transfer is successful, as well as help you increase the utilization of your bandwidth, you can use multipart uploads to spread out that upload process into many smaller chunks. The process is very simple. It's a three-step process. You first initiate a multipart upload. We then pass you back an upload ID, which you then pass back to us with every part that you send to us. And then once it's complete, you send a complete multipart upload call, at which point we'll then send you the archive ID representing the sum of those parts that you uploaded. So as I mentioned earlier, accessing Glacier through Lifecycle policies is a great way to use Glacier, especially if you have other tiers of storage in S3 standard or S3 standard infrequent access and want to tier your storage over the life of those objects into Glacier. Lifecycle policies are applied based on the age of the data and can be transitioned downward into infrequent access or into Glacier, and then eventually to be deleted. In the example here, objects that have the prefix logs and that are 30 days old are transitioned to Glacier and then deleted after 365 days. Lifecycle policies apply at the bucket level, but you can go a little bit more granular by specifying the prefix that you want to apply. And so what that means is that all objects that meet that criteria will have the lifecycle policy executed on it. Now, a lot of customers store all their objects or a large portion of their objects, in particular for particular applications, in one bucket for application design reasons. And so some customers have said that it's been challenging for them to transition only the objects that they want transitioned into Glacier. And they don't want all of them from the bucket to do that. And they've had a hard time defining policies that are able to do that. So I'm very excited about S3's announcement yesterday around object level tagging, because it's integrated with lifecycle policies and now finally enables you to create very specific lifecycle policies that apply only to the objects that you want transitioned to Glacier. So the way this works is an object you can, well, just looking at the example here, This policy, which applies to all objects in the bucket, will only apply to objects that are tagged with project equals delta and data type equals HPI. So you can imagine this allows for a lot of customization. One other thing that customers have asked for a long time is the ability to manually transition objects from S3 into Glacier explicitly, rather than through a lifecycle policy. And this is now possible using object-level tags and lifecycle policies. And the way you do that is create a zero-day policy, meaning that any objects that match the criteria are transitioned immediately, and then having a tag that you can then, a tag reference in that policy that you can then tag an object with, which will then trigger it to be transitioned into Glacier. And so, for example, you can create a policy that says, a zero-day policy that's, refers to any objects with the tag, freeze it. And, then with the new object-level tagging, you can simply make a call on an object to add the tag, freeze it, at which point it'll be immediately frozen into Glacier. That joke did not go over very well, but that's okay. I'll work on it. Okay, lots of other management features to help you manage your Glacier account. Tagging is at the vault level for Glacier, and it enables you to do things like look at your costs across different departments, or however you're managing your vaults via tags, as well as to create access policies based on those tags, which makes it really easy to customize those access policies. We also are integrated with CloudTrail. A lot of customers use archive storage for mission or business critical data, and so it's really important for them to know who touched what, when, was it approved or denied, and for what reason. So enabling CloudTrail enables you to have access to those logs, and it's very simple. You just go into the console and turn it on. We also offer two really powerful access features. The first is vault access policies. So rather than having to go through each of your users or your groups to define what they have access to, you can create access policies at the vault level that apply to all users. So for example, if you want a vault where nobody has access to deleting the data in that vault, you can do so using vault access policies. But more importantly, vault access policies enables cross-account access to the data in your vault. This is particularly important for customers who work with other departments or other third-party entities that have separate accounts, but are part of whatever workflow they're working on, and this makes it very easy to give that access to other accounts. A very powerful governance tool is Vault Lock. Vault Lock enables you to create an immutable access policy on a vault where not even the root user is able to change that policy, and this is required for certain regulations, in particular in the financial services industry. So to go over an example, let's jump to the example here. So to give you an example, in this example, we're combining the use of tags on a vault as well as vault access policies to enable legal hold on a vault. So here you create a tag called legal hold on a vault, and you initially set it up as false, and then you would create a policy that denies delete archive operations for all users when that tag is set to true, and then and with this policy, a lawyer, for example, could place a legal hold on a vault for the data for whatever reason. The vault lock is a two-step process. You first initiate a vault lock, and this allows you a 24-hour period to test that policy to make sure it's exactly what you want before making it immutable by even the root user. That'll then expire after 24 hours, or you can simply delete it in order to change it before locking it. Once you're sure that it's good to go, you then complete the vault lock, and it then becomes locked and immutable. Some best practices, oh, by the way, this is what that policy looks like. Very simple, very short, a few lines of code, but very powerful. You can see here the effect is deny on the operation delete archive, and the reference to the tag legal hold there at the bottom. Some best practices around vault lock. It's a good idea to map one vault to a single retention range, so 1 year, 6 year, what have you. Makes it easy and simple to create policies that apply to all the objects or archives in that vault. It's also a good idea to create a new vault and lock it before storing any data in it to prevent any gaps in those existing archives. And then lastly, again, make sure you really thoroughly test that vault lock policy before locking it down. And then, consider using vault access policies for any flexible controls that you might want to change over time versus this immutable policy. And lastly, on vault lock, we had a third-party assessment by Cohasset Associates who verified that it passed muster, if you will, for SEC 17A-4F and CFTC 1.31B-C, which are table stakes requirements in the financial industries for financial industry companies. And as we continue to get feedback and requirements, you can expect us to add more algebraic formulas to this list. Also not a joke that went over very well. I really got to work on that one. Okay, that's cool. You guys just want to go to pub crawl. I get it. It's fine. Okay, so last section here is around retrieving your data. So some basic concepts here. When retrieving data, it's a two-step process. First, you initiate a retrieval request, at which point we'll give you a job ID. Then that retrieval request is processed by Glacier, depending on the retrieval option that you choose. It could be minutes or hours, depending on the option that you choose. Once it's complete, we'll send you a notification that that retrieval job is done, at which point that object or archive is ready to be used or downloaded. To illustrate what this looks like for customers who are using Glacier via Lifecycle policies, you can retrieve data using the console. You can simply select the archive, or in this case, object that you want to restore. You'll then be prompted to specify how long you want that data to be usable. And to clarify, the retrieval process is not a move, it is a copy. It creates a temporary copy that is then made usable, and the original is still kept durably stored in Amazon Glacier until you choose to delete it. You'll notice in the console that the restoration is in progress during the 3 to 5 hours, or depending on which retrieval option you choose. And once it's ready, you'll see the time period during which it's made available, as if it were stored in S3 standard. We also offer a retrieval policy tool to help you control your retrieval costs. You can choose between 3 options. One is to keep your retrievals within the free tier, which is 10 gigabytes per month, which you can use at any time. And with this, your request will be synchronously rejected if you surpass the free tier. You can also choose a max retrieval rate that's applied at an hourly rate in order to control your cost that way, or you can simply put no limit on the amount of data you can retrieve from Glacier. And coming back to the multi-part uploads, if you were to aggregate your data and separate them by file and include the checksums, we enable range retrievals. So if you know a priori the byte range that you want to retrieve from that archive, you can pull just a chunk of that archive without having to pull the entire archive itself. And this can help reduce and minimize retrieval costs. Lastly, and most excitingly, last week we launched new retrieval options. So until last week, there was one option to retrieve data in 3 to 5 hours from Glacier, and it was accompanied by a very complex pricing model based on the rate at which you retrieve data. And we have completely replaced that pricing model with a simple, flat, per GB price of 1 cent per gigabyte. Retrieve 1 gigabyte, pay 1 cent. It's simple, it's predictable, and should make accessing your data much easier and a much lower cost. But customers also told us that they wanted to occasionally get at their data quicker, and they also asked for an option to retrieve large amounts of their data for a very low cost. And so we introduced expedited retrievals and bulk retrievals. Expedited retrievals enabled you to get your data in 1 to 5 minutes. It's really designed for just that rare, occasional, urgent requirement for a small subset of your data or a few archives. You pay a little more, it's 3 cents per gigabyte, and it's 1 cent per archive, compared to standard retrievals, which is 5 cents per 1,000 archives. So it's really designed for when you, in that rare occasion when you need your data really quickly. And then, as I said, customers also asked for a way to retrieve large portions of their data, and so we introduced bulk retrievals, which is a highly cost-efficient way to retrieve even petabytes of your data within 12 hours. And that the cost is low, 1/4 cent per gigabyte, and 2.5 cents per 1,000 archives. And this is going to be, I think, a really powerful tool for that will enable all sorts of use cases, more active use cases, such as mass content distribution, big data analytics, et cetera. And so with these 3 retrieval options, you can choose which option you want simply by designating a parameter, a new parameter that's included in the retrieval API. And if you don't specify, the default option will be standard. So if you have existing applications today and you're not specifying, those will still work and will continue to just be retrieved at the standard retrieval rate. So with this full set of 3 retrieval options, Glacier is really now more than ever able to address the full spectrum of archival workloads, ranging from deep archives that take advantage of Glacier's extremely low storage cost, all the way to active workloads like media transcoding, content distribution, big data analytics, what have you, that not only store petabytes of data, but also retrieve petabytes of data, all at an extremely low cost. And so without further ado, it's my pleasure to introduce Andy Shenkler from Sony DADC to tell us all about how they chose to go all in on AWS and leverage Amazon Glacier to power their application venue. Everybody welcome Andy.
Thank you. Thanks. Good afternoon. I have a short 75 deck slide deck here for you. No, it's going to be pretty quick. Mas was right. We made a choice several months ago to go all in with AWS. And when I say all in, we had on-premise facilities in our Marina Del Rey office, London, and a large data center in Phoenix, Arizona, and we are exiting all of them. And we will be exiting all of them by the end of our fiscal year, which is March of next year. And everything that we do will be running on AWS. And to give you a bit of a view of what we do, we run global supply chains for Sony Pictures, BBC Worldwide, Village Roadshow, back-end solutions for PlayStation, OTT services for companies like Funimation, and a wide range of others. And it's everything from content distribution out to about 1,500 different endpoints globally, as well as running full linear playout services, as well as OTT and commerce solutions. And to get a sense of, you probably all know a little bit about how the world has changed in the media lifecycle, but to get a good sense of it, if we just look at how media releases have changed over the last several years, even the last several days, it feels like. We used to have very long windows of time. We used to have periods of time where something would come out theatrically or get released, as a show on TV, and then you might have it be on airlines, and then it goes to cable, and then it goes to home entertainment. And that was a very long period of time. And that time frame is completely consolidated now, and it's somewhat unpredictable, right? And we've seen it just with, I know nobody wants to talk about the election, but we've seen it how, social media has absolutely created this vacuum for all of this information that needs to be readily available, and people need to be able to pull stuff on demand. And so the problem that we started to struggle with is, how do you fulfill that, right? And if you're using a data center where you have a fixed set of capacity, or a long period of time where you can actually procure more equipment, how can you possibly expect to keep up with the times? And so, one of the things that I constantly say, especially as we look at Amazon.com, not even the AWS side, is if I can go online and order a product and it's at my house within an hour, physically, in Los Angeles, with all the traffic, how is it possible that digitally I can't do the same thing? That is a metric that should absolutely be the standard for everybody to do something. And what's incredible is when you work in the industry for as long as I have, people talk about things on the measure of days. It's really becomes the exception to the rule when somebody says, well, I need to get something out and it's got to happen tonight. And it takes a team of people generally, working together to make that happen. That should not be an exception process. That should be the absolute standard, right? And we live with these problems of, we've created what I call emotional prioritization that computers don't understand, right? Somebody will call up and say, I need this right now, and they start moving stuff, and we created priorities, and then we have high and urgent and super urgent and all sorts of ridiculous concepts that we apply because we're humans and we tend to group things. But meanwhile, if you can just scale, you don't have that problem at all. You can just scale to fit your needs. And so Glacier was actually a really big piece for us when we were looking at this, because in order to make it cost effective in an offline world or a non-cloud-based world, we were all tape driven, right? We were using large LTO libraries. I think we actually had one of the largest in the country, something on the magnitude of 9,000 to 10,000 tapes in a robot at all times, because we couldn't afford to have any delay where somebody had to go look it up and go put a tape into a library. So we kept everything in the robot all the time. Well, robots break. They're cool, but they break. And we needed a mechanism to be able to kind of keep up with what's going, right? So our challenge was, how do we take 20 petabytes of content? We store about 1 million hours of content today. That's growing at about a petabyte a quarter. We've started to see a little bit of an inflection, and that's even getting higher. And how do we turn that into our desired goal of 1 hour delivery that's in a predictable and scalable environment without having to constantly invest in major capitalization initiatives? We wanted to move our money and investment into innovation and stop having to worry about 3 to 5 year life cycles of hardware and investment in that model. So this is what our workflow used to look like, right? It really used to look like, and many of you probably have similar things to this, both from a security perspective and just how many touch points we had to have in the different storage zones that we needed, the number of hops and movement of an asset coming into our environment and having to go all the way through our workflow in order to be able to facilitate that endpoint distribution is fairly massive. So what we've tried to kind of diagram out here a little bit, and this is at a high level, 120 gigabyte ProRes file is, roughly the size of a normal HD movie, right? And I think as everybody's starting to see, even HD movies are now becoming, the smaller size asset that we're dealing with. We're dealing with 4K an awful lot at Sony. We're starting to see some 8K test files come in. Those present all new challenges for us that this workflow just simply would not accommodate, right? We get files in from various sources all over the world, usually using Aspera or Signient or some other type of file transport accelerator. And even if we have an unlimited amount of bandwidth, it's very rare that the people who are sending to us or receiving from us have that same level of infrastructure and bandwidth that they can support those kind of speeds. So we see things about 300 megabits a second. We actually have some fairly funny anecdotes of things like we sent to a facility for a broadcaster in South Korea, and over one weekend, it just stopped receiving. We called and we said, what's going on? We can't send you content. It turned out that the operator just took the computer home for the weekend. Like, those are real world scenarios that we deal with, right? So, I'm delivering to somebody's cable modem. So you start looking at, the source asset comes in, it's 300 megabits a second, takes an hour to get in there. We put it onto some DMZ storage, right? We obviously have some, pretty specific security arrangements where we're never going to let people get to, the deep archives or the work in progress storage that we have. We then have to move that either through our own internal movement process or fiber connections that we run behind the DMZ. That goes into quarantine. It then has to be evaluated. That then has to lay back to tape, because all of the workflows are, whether it's using a front porch library or something like that. And so now you're limited by tape speed. Now, what tends to happen is when we talk about these workflows, people just naturally gravitate to a single file, right? It's like, oh yeah, it's not a big deal, we can get one file through. We process somewhere between 50,000 and 60,000 titles a month. And what's really important about that is not the fact that the numbers are that size, it's that it's a completely unpredictable model in terms of when that request comes in, right? It's not smoothed at all. It's not like somebody tells us in the beginning of the month, hey, I'm going to do 60,000 title deliveries, and so let's just average it out. It comes in, and we don't know whether Sony Pictures or BBC are going to place orders on the same day. We don't know whether it's going to be a lot of television shows or a lot of feature films, and we don't know where they're going. And so you start to look at this and you say, well, how on earth am I going to get through an X number amount of content, right, which represents, Y petabytes, and I have no predictability and no mechanism to smooth that out, and my entire limiting factor here is a tape library that may go down, I may have an outage of some type, the tape may be bad and I have to go retrieve a second copy. Like, there are a number of things that really come into play that you have to think about when you're dealing with those kind of scales. And then, of course, you go all the way through, there's work in progress, and work in progress, this doesn't even contemplate the concepts of transcoding, packaging, all of the things that create other latency issues beyond just moving a file through the workflow. And of course, at the beginning and end, as we talked about, finite capacity. So that's when we really started to look at how does this cloud storage model help us? And as Maz just talked about, we're certainly incredibly happy about the new expedited retrieval model, especially when you start looking at how are we going to do 20,000 titles and I want to deliver everything in 1 hour. If my first bottleneck was a retrieval time, that's now been eliminated. Now I can focus on everything else that comes in. So we finally have a period here where we effectively have infinite concurrency. I no longer have to worry about that scaling problem. I no longer have to worry about whether or not a tape library is going to go down. And using, we use the lifecycle management, right? And using those policies, I no longer even have to worry about controlling when something is on tape or off tape, or actually going in and touching assets that have been sitting on a tape for a year or a year and a half that nobody's ever ordered again because it was used once for something and then we haven't touched again, and concern myself whether or not that's a good asset. Those are all things that we just no longer have to deal with. We can go focus on, really honing in our business processes and just not worrying about it. We look at Glacier now very much like we look at power. I don't spend a lot of energy calling the power company and really questioning how it is that they're getting electricity in my house. I have better things to do. I just want to go play with the new drone that I plugged in and used with it. Glacier's been really helpful for that. And I must also say the 11 nines of durability has been a really big helper. We have been storing 3 copies. I know that you saw some stats before about 2 copies. We've been storing 3 copies of assets. And the 3 copies of assets, while it creates a lot of protection for us, it takes an enormous amount of overhead for us to have to make 2 separate copies of everything, ship 1 off-site, keep 1 right outside the robot, and then the 3rd copy in the library itself. The amount of tape drives that I need to keep running 24 hours a day that aren't actually generating any revenue for our company, but just making backups, that's a huge amount of overhead. And that's a real big concern for us. And so, we hear the great anecdote of, you store something with 11 nines and you lose an object every 10 million years. And I like to say, the moment somebody gives me a 10 million year contract, that's the first time I'll worry about whether or not I have to actually deal with losing a file on Glacier. One of the things I get asked a lot when we're talking to other companies or clients or whomever is, well, that's great. A lot of people are looking at the same things. They're dealing with the same kind of problems. It really becomes an economic problem. And so what we decided to do is just share our economic model. And I think this may help some people, right? And so we were at a point in time last year where we had to make a decision to replace our tape library, right? We were using LTO5. We had been, from a mindset perspective, jumping every second version of LTO. So we were going to do an investment and upgrade to LTO7, or actually we were even looking at some newer technologies from IBM that would give us 10 terabyte tapes, which of course, in either of those scenarios, we were going to have to replace every single asset that we had. We were going to have to migrate everything to a new tape format. We were going to have to create new secondary tapes. And so you have this problem where we were going to have to make a decision that if we did that, we were not going to the cloud. We cannot afford to process and deal with 20 petabytes of content that's growing at the rate that it is and have it be kind of hybrid. That's just not realistic. We see competitors of ours putting out press releases, recently that say, hey, we've bought a new tape library and we put one in London and one in Burbank. And I can only feel like that must have been what the turn of the last century was, when somebody saw the car and was like, hey, we just bought a new horse and we just bought a new whip and it's going to be the best thing ever. And then 3 years later, they're still feeding that horse and everybody else is driving around in a car. Like, that's ridiculous. And so we made a conscious decision that we were going to have to do a wholesale change and move everything that we have. And so what you see here is that blue line represents a reinvestment in the tape library up front and migrating all the assets. And we actually created a better model for the tape library and a worse model for AWS, right? As we've just seen today, they've lowered the price, which was wonderful for Glacier and for us. We did not take into account any price reduction on Amazon. But we did take into account tape reduction prices as we look at the multi-years. And what we said is, even in a 5-year period, we have over a $5 million savings just based on the infrastructure investment alone. When you take that out 7 years, because you assume that there's going to be yet another hardware refresh required in a tape library, now you're looking at something on the magnitude of $10 million in savings, all based on the growth and the model that we're talking about. So for us, moving into Amazon wholesale, even if we just looked at it from a pure Glacier perspective and nothing else, made absolute sense. All of the other byproducts and benefits that we get from it is just icing on the cake. And that's why we started with the team from Glacier, and we were really focused on how do you go about, nobody had a snowmobile when we started, right? It would be great if somebody pulled up a giant truck with 100 petabytes of storage. That did not exist. We are moving everything, and we're almost finished with it, but we moved it all just using multi-part transfers. And so, that's been really critical for us. And I think that as you guys look at some of your own workflows, as you're evaluating these things, we just want to share. We just want to share what it is that we're doing and how we came to these conclusions. And you can just see from the terabytes stored and the price point, it just really works very well for us, and it puts us in a very unique position to be able to deliver on promises to our clients that are really necessary for what's happening in the market today, right? Which just hasn't been possible before. So, I was kidding about the 75 slides. That's all I've got for you. So thank you.